Welcome. Today we are looking at atomic structure, Part 1. This is a key topic in your chemistry exams for SS1. Pay close attention. Let us begin. First, let me explain what an atom is. An atom is the smallest particle of an element that can take part in a chemical reaction. Atoms are the basic building blocks of all matter. They are very small. They cannot be seen with the naked eye. The word atom comes from the Greek word atomos, which means indivisible. Ancient Greek philosophers believed that atoms were indivisible. Today, we know that atoms are divisible into smaller particles. These smaller particles are called subatomic particles. The three main subatomic particles are protons, neutrons, and electrons. Protons have a positive charge. Neutrons have no charge. Electrons have a negative charge. Protons and neutrons are located in the nucleus at the center of the atom. Electrons orbit the nucleus in energy levels or shells. Now, let me explain the historical development of atomic theory. The idea of the atom has evolved over time. The first atomic theory was proposed by John Dalton in 1808. Dalton's atomic theory had several postulates. First, all matter is made of atoms. Second, atoms are indivisible and indestructible. Third, atoms of the same element are identical. Fourth, atoms of different elements are different. Fifth, atoms combine in simple whole number ratios to form compounds. Sixth, atoms cannot be created or destroyed in a chemical reaction. Dalton's theory was a major step forward. However, it was later found to be incomplete. We now know that atoms are divisible into protons, neutrons, and electrons. We also know that atoms of the same element can have different masses. These are called isotopes. The next major development was J. Thomson's discovery of the electron in 1897. Thomson was studying cathode rays. He found that they were made of negatively charged particles. He called these particles electrons. Thomson proposed the plum pudding model of the atom. In this model, the atom was a sphere of positive charge with electrons embedded in it. This was the first model to include subatomic particles. However, the plum pudding model was later disproved. The next major development was Ernest Rutherford's gold foil experiment in 1911. Rutherford fired alpha particles at a thin sheet of gold foil. Most of the alpha particles passed straight through. Some were deflected at small angles. A few bounced back. Rutherford concluded that the atom is mostly empty space. He proposed that the atom has a small, dense, positively charged nucleus at its center. The electrons orbit the nucleus. This was the nuclear model of the atom. Rutherford's model explained the results of his experiment. However, it could not explain why electrons did not spiral into the nucleus. The next major development was Niels Bohr's model of the atom in 1913. Bohr proposed that electrons orbit the nucleus in fixed energy levels or shells. He called these shells orbits. Electrons can jump from one orbit to another by absorbing or emitting energy. Bohr's model successfully explained the hydrogen spectrum. However, it did not work for more complex atoms. The modern quantum mechanical model is based on the work of Schrödinger and Heisenberg. It describes electrons as waves and particles. It does not give exact orbits. It gives probabilities of where electrons are likely to be. These regions of probability are called orbitals. Now, let me explain the subatomic particles in more detail. Protons are positively charged particles found in the nucleus. The number of protons in an atom is called the atomic number. It determines the element. For example, all hydrogen atoms have 1 proton. All oxygen atoms have 8 protons. Protons have a relative mass of 1. Neutrons are neutral particles found in the nucleus. They have no charge. They have a relative mass of 1. Neutrons help to hold the nucleus together. Electrons are negatively charged particles found outside the nucleus. They orbit the nucleus in energy levels. Electrons have a very small mass. Their relative mass is about 1/1840 of a proton. They are responsible for chemical bonding. The number of electrons in a neutral atom is equal to the number of protons. The mass number of an atom is the total number of protons and neutrons in the nucleus. The atomic number is the number of protons. The number of neutrons is equal to the mass number minus the atomic number. Now let me explain isotopes. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. They have the same atomic number but different mass numbers. For example, hydrogen has 3 isotopes. Protium has 1 proton and no neutrons. Deuterium has 1 proton and 1 neutron. Tritium has 1 proton and 2 neutrons. All 3 are hydrogen. They all have 1 proton, but they have different masses. Isotopes have similar chemical properties. This is because chemical properties depend on the number of electrons, which is the same for isotopes of the same element. However, isotopes have different physical properties. For example, they have different densities and boiling points. Isotopes are important in many applications. Radioactive isotopes are used in medicine for diagnosis and treatment. They are used in carbon dating to determine the age of fossils. They are used in industry to detect leaks and measure thickness. Now, let me explain the arrangement of electrons in an atom. Electrons are arranged in energy levels, or shells, around the nucleus. The shells are numbered 1, 2, 3, 4, and so on. Shell 1 is closest to the nucleus. It has the lowest energy. Shell 2 has higher energy. Shell 3 has even higher energy. The maximum number of electrons that can fit in a shell is given by the formula 2n squared, where n is the shell number. For shell 1, the maximum is 2 electrons. For shell 2, the maximum is 8 electrons. For shell 3, the maximum is 18 electrons. For shell 4, the maximum is 32 electrons. The arrangement of electrons in shells is called the electron configuration. The electrons fill the shells in order of increasing energy. The first shell is filled first. Then the second shell is filled. Then the third shell. The outermost shell is called the valence shell. The electrons in the valence shell are called valence electrons. Valence electrons determine the chemical properties of an element. Elements with a full valence shell are stable and unreactive. These are the noble gases. Elements with 1 or 2 electrons in their valence shell are reactive metals. Elements with 5, 6, or 7 electrons in their valence shell are reactive nonmetals. Atoms tend to gain, lose, or share electrons to achieve a stable electron configuration. This is the basis of chemical bonding. Now, let me explain the difference between atomic number and mass number. The atomic number is the number of protons in an atom. It is the identity of the element. For example, carbon has an atomic number of 6. This means it has 6 protons. Oxygen has an atomic number of 8. This means it has 8 protons. The mass number is the total number of protons and neutrons in an atom. It is the mass of the atom. For example, carbon 1,2 has 6 protons and 6 neutrons. Its mass number is 12. Carbon uncath has 6 protons and ut neutron. Its mass number is 14. Both are carbon. They have the same atomic number, but they have different mass numbers. They are isotopes. The symbol for an element is written with the atomic number as a subscript and the mass number as a superscript. For example, 12/6c is carbon. 1, 2, 0. 14/6c is carbon. 1, 4. Now, let me explain the concept of relative atomic mass. The relative atomic mass is the average mass of an atom of an element compared to 1/12 of the mass of a carbon 1,2 atom. It is a weighted average. It takes into account the abundance of each isotope of the element. For example, chlorine has 2 isotopes. Chlorine 3,5 has a relative abundance of about 75%. Chlorine 3,7 has a relative abundance of about 25%. The relative atomic mass of chlorine is calculated as follows: 35 time 0,75 plus 37 time 0,25. This gives 26.25 plus 9.25. The sum is 35.5. So the relative atomic mass of chlorine is 35.5. This is the number you see on the periodic table. The relative atomic mass is not a whole number because it is an average. It takes into account the different isotopes and their abundances. A common exam question asks you to define atomic number and mass number. Here is a sample answer. The atomic number is the number of protons in an atom. It determines the element. The mass number is the total number of protons and neutrons in an atom. It is the mass of the atom. The number of neutrons is equal to the mass number minus the atomic number. For example, an atom with atomic number 6 and mass number 14 has 6 protons and 8 neutrons. Another exam question asks you to explain isotopes and give examples. Here is your answer. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. They have the same atomic number but different mass numbers. Examples include hydrogen 1, hydrogen 2, and hydrogen 3. They all have 1 proton, but they have 0, 1, and 2 neutrons, respectively. Isotopes have similar chemical properties, but different physical properties. Another exam question asks you to describe the historical development of atomic theory. Here is your answer. Dalton proposed that atoms are indivisible and indestructible. Thomson discovered electrons and proposed the plum pudding model. Rutherford discovered the nucleus and proposed the nuclear model. Bohr proposed that electrons orbit in fixed energy levels. The modern quantum mechanical model describes electrons as waves and particles. Each model built on the previous one and corrected its limitations. Let me give you a quick summary. Atoms are the basic building blocks of matter. They are made of protons, neutrons, and electrons. Protons have a positive charge. Neutrons have no charge. Electrons have a negative charge. Protons and neutrons are in the nucleus. Electrons orbit the nucleus. Atomic number is the number of protons. Mass number is the number of protons plus neutrons. Isotopes have the same number of protons but different numbers of neutrons. Electrons are arranged in energy levels. The outermost electrons determine chemical properties. Practice these concepts. When you have them down, move to topic 5.